Hello, everybody. After our short break, and now with me is Fredrik Carleson. Hello, Fredrik. Nice to meet you.
Hi, nice to be here.
Yeah. So, Fredrik will tell us something about DevOps culture and things related to this, some troubles, some issues, maybe. So, Fredrik, one open question, for the beginning. So I'm assuming that from your presentation, you will tell us that DevOps is a culture, not let's say the position. But I often see some job offers in the internet that hey, we are looking for DevOps engineer, and I'm always thinking, what does it exactly mean? So, what do you think about that kind of job offers, that kind of organization which are preparing that positions? Yeah.
Well, I think it's good that organizations begin to understand what DevOps is. I hope that the organizations that post these offers also understand what it is and not make it into some kind of a role with specific uh, description of what you have to do or not to do, and that you're not trying to make it into a framework of some kind. But
Mhm.
I think it's still good. DevOps is a good thing, and I think we need more DevOps in companies.
Yeah.
And so, if just ask questions, to see if they know what DevOps is in a company.
Yeah, exactly. I'm thinking that it's always good to make that kind of education that hey, DevOps, it's not just the defined position, it's kind of way of working, kind of culture inside an organization, not a position. Okay, Fredrik, so the floor is yours. Keeping fingers crossed for you and for your presentation. That have fun.
Thank you so much. Let's see. So, welcome to this session where I will talk about DevOps, and also, I will wear 8 different hats. So, I'm Fredrik. I belong to the Commodore 64 generation. I am actually so old that you cannot copy and paste code from the internet when I grew up. You had to borrow computer magazines and you had to copy paste code manually by typing it in. And I've been professionally in the software industry since 1997. I've been playing a lot of role-playing games. And when I came across Scrum in 2008, I immediately recognized that Scrum had copied the entire concept of role-playing. For example, in role-playing, you had dungeon masters. In Scrum, you have Scrum masters. In role-playing, you form cross-functional teams. You have wizards, you have warriors, and thieves. And in agile teams, you also have cross-functional teams. You might have programmers, testers, operations people, UX, and if you're unlucky, you might have a thief in your team as well. In role-playing, a dungeon master tells stories, and then the team has to act upon the story. And mostly in many of the agile companies, you have user stories that the team has to act upon. In my life, I've tried various approaches. I've tried waterfall, restaurant unified process, Scrum, Prince 2. I also tried less and also safe. I'm also an editor and writer at Serious Scrum, which is the largest independent Scrum community in the world. So there are many ways to describe DevOps, but the DevOps handbook summarizes them like this. Flow is about having work flowing as fast as possible throughout the process or value chain. And there's usually a lot of waste that stops our flow. And feedback is about getting the correct information when you need it and doing something about it. And flow allows us to put something into production fast, and then feedback loops and that enable us to learn. So then continuous learning is about reinforcing what has been previously learned and ensure it either does or does not happen again. Then you have the value stream, which is the necessary activities or steps required to realize the value from start to finish, often from a customer-centric perspective. Then you have the theory of constraint, which simply put is about finding and removing the worst constraint or bottleneck. And as we eliminate constraints, we get better flow and cycle times. And then system thinking is about trying to understand how various parts in a complex system affect each other, where there is seamless no cause effect. And we try to understand everything by looking at the whole picture. So what is culture then? Well, perhaps it's a good definition to say that we base our actions based on how we believe things are. For example, we have the famous philosopher René Descartes, and he said that we have 4 different fluids in our body, and we should not mix these fluids because it's not good for you. Therefore, in Sweden, we actually built beds so you could sit and sleep, because if you lie down, the fluids would mix, which was not good. In Star Wars, the culture of the Empire is based upon the values of the dark side. It creates a culture based on fear and power and control and hatred. A very memorable scene is when Darth Vader says, "I am your father, Luke." And that completely disrupts Luke's perception of reality. And for many, DevOps is still disruptive and requires new ways of thinking. And changing your way of thinking is very difficult indeed. So, theories are usually perfect until you involve people. The second people get involved, things get complex, and theories tend to fail. And that is because we make compromises, and doing the same thing twice might actually give a different result. So no one, of course, wants a toxic culture, and still that is what we seem to end up with. So how can we be strong in the force and not be seduced by the dark side like Anakin? And I think the answer is culture, or rather what constitutes your beliefs. That is, theories and facts do not convince us. It is emotions and stories that guide us. So I will now present 8 real scenarios where culture was a barrier to success and how we try to solve the issues. And remember, these examples are not perfect or complete. They are from real life, and because of that, full of compromises. You will see some boxes showing the active mindset. Try to think for yourself how these can help. So, I promise you hats. So, in the first one, I work for a company that sells a market leading product. As a dev manager, my main job was actually to escalate problems, do firefighting. Issues that should take minutes to fix took weeks. And to deploy a new version required heroics every time. Priority was changed based on which customer that shouted the loudest or whom the country manager just had lunch with. And we were a typical product organization, so we divided into departments for sales and operations, help desk, dev, and so on. And of course, each department had its own business goals and its own managers. And of course, they were all in conflict with each other. And we had KPIs which intensified the conflicts. For example, sales, they had aggressive goals to sell as much as possible. And they were outstanding. They sold so much. The problem was that they had sold for 5 times more than we could deliver. And of course, they had promised dates when we would deliver it. So I went to talk to the sales manager, and he just looked at me and said, "I don't understand your problem. How can this be a problem? It's great that we have sold so much. Just hire a few more people. You should be able to afford it. How hard can it be?" And I wish it was that easy. Just hire a person and they will deliver fantastic software from day one. Why do non-IT people believe this works? Building software for me is more like having 15 drunk chaos monkeys trying to complete a jigsaw puzzle. But we said, all right, we'll do our best. We'll focus really hard on delivery. So what is then the natural response from a dev team under pressure when scope cannot be delivered? They pee in their pants. Yeah, that's right. We do quick and dirty solution, and we build technical depth. That is like peeing in your pants. It feels warm and pleasant for a little while, and then we pee and we pee again. So, what is then the consequence of lowering quality? Well, you get more bugs and errors in production. Helpdesk had a service level agreement, SLA, and they need help from us in the dev team to fix bugs and avoid costs. So after some time, helpdesk gets overwhelmed. So the helpdesk manager comes to me and says, Fredrik, what the hell is happening? We have so many bugs in production. I need some help. So what was my answer? Sorry, we don't have time to help you. We have so many new features to deliver that we can't spare a single person. But hey, sales, they made a lot of money for us. Why don't you go out on the street and hire some help desk assistants? How hard can it be, right? All right, so now we are in a situation where we're under even more pressure to fix bugs and deliver more features. We had to pee so many times. So what about operations? Well, operations had to cut costs by 20%. Upper management only saw operations as a cost center and constantly wanted to reduce costs. So how happy do you think the operations manager was when I demanded 50 new test servers for all our new customers? Not happy at all. He bluntly told me, you will not have a single megabyte more. So what did I say? But hey, sales, they have made so much money for us. Why don't you just buy some servers from the local store? How hard can it be? So, can you see how selfish everyone is? The underlying problem here is, of course, that we work in silos. We have sub-optimized goals, and we cared only for our own goals, but we forgot to look at the whole. So, what did we do? Well, operations had to save money, but I did have money. So we moved three technicians from operations to my unit. We placed them in a room together with developers, and their focus was to make sure that we had environments up and running when needed. And their focus was also to make sure to shut them down when not required. And then together to work on automation scripts and fixed batch scripts and other things that seriously only ran because of the love and massaging of some caring people. We also created a dev help desk team to fix some bugs. At first, we put some junior programmers in this team, but that really didn't work because they didn't have the knowledge. And also, they had to run to the senior programmers all the time. So we put a senior programmer into the team, and then it worked really well. And it was a help desk manager that prioritized this work continuously all the time. And any spare capacity was to be used to do some refactoring and write unit tests. So system thinking helped us to understand how our actions negatively affected other departments. We had to understand our bottlenecks, and efforts helped us to fix bugs faster, to have cleaner code, and to have environments up and running when needed or not needed. And we got a better focus for teams and some faster flow and good feedback earlier on. So, shop. Next one. So, this picture shows the difference between an autonomous cross-functional team and a specialist team. And we often live in the delusion that if we use specialists, we can get the job done faster. If everyone works really fast, and we must be fast, right? This can work in a stable, predictive environment without variation. Creating software is complex with unknowns. We often have unpredictability and unknown capacity. So the conveyor belt approach is not really suitable. That would be like having a conveyor belt moving at various speeds with random unknown parts, and the customer constantly changing his mind about what we should build. In software, specialists usually create queues instead, which means that things go slower even if they are fast. So look at the top. We have a specialist front-end team who does their part in 5 hours. Then they hand over their work to the back-end team, and before they can start working on it, because they have different priorities, maybe something else is more important, it takes 10 days. And then they complete the task in 9 hours and ask the team, another team that is, to test, which they do maybe 5 days later. And finally, they wait for the next release window 2 weeks later. So the total touch time doing something of value is roughly 20 hours, but it takes 36 days. And the task involves 3 teams. And of course, you need a manager or something to handle it because coordination is difficult. Well, the picture below instead shows a cross-functional team, which I'm sure you're all familiar with. And they have all the skills and they have good engineering practices and continuous deployment, or maybe at least CI. And they do the work without handovers and use automation. And as you can see, the total time to production in this time is 20 hours. So you can see slow deliveries are often due to dependencies and handovers, relearning, incomplete work, and waiting. That is basically the 7 ways, as Popendick says. Even if a team or a team member is ready with their work, waste arises due to ineffective collaboration with other teams or departments. So my experience is that the larger the organization, the more of these constraints you have. Even if you have a fantastic cross-functional team that can check in functionality daily, it is still common to have bottleneck across teams. And this problem occurs both at team and value stream level. So how long it takes from idea to production is critical because it provides mechanisms for quick feedback, allowing us to make better decisions. So if we agree that time is the most vital factor, knowing where we have bottlenecks is essential to understanding where the flow is interrupted. So now imagine a company with over 1,000 people in the IT department. They are going from classical PM3 to implementing a comprehensive scaling agile framework using a Big Bang method. And you're divided into value streams. Again, a value stream is the necessary activities, usually from a customer perspective, you have to perform to deliver. And you measure cycle and lead times to see where you have constraints and you remove them to get a better flow. Persons in an efficient value stream have the ability to improve their flow. Value streams are good in theory, but very difficult to get right in practice, regardless of the scaling framework. So the company in this scenario, they had a complex organization with several legacy systems. And each system had different architecture and technology and lots of integrations. And the organization was traditionally organized around products. So the organization first tried to divide into value streams, but realized it's very difficult to create value streams based upon customer-centric perspective. It was much easier to create a value stream around existing products. So that is what we did. Now, imagine you creating epics and features that are customer-centric. Can any value stream then take a feature from start to end? In this example? That's right. They can't. Why? Because each feature requires changes in several products. So you need work to be done in several value streams. Value streams set their own priority and determine their own work, but somehow they have to sync to deliver something of value, and it gets very complicated and messy. Now, imagine that you have fast and efficient teams in the value streams. Does it matter? No, it doesn't, because the teams are just a tiny part of the entire chain to create value. One team or value stream cannot autonomously deliver anything of value, and they cannot decide on priorities outside their team. So what's the result? Well, it's handovers, it's power games, massive coordination efforts. which led to unfinished works, queues, waiting, slow feedback where no one is accountable. What was the solution? Well, in this case, adding a layer on top to coordinate across the value streams. Did it help? Well, somewhat. But did it resolve the root cause problem of having false value streams? No, not really. So collaboration between several different value streams and teams is hard, it's slow, it's inefficient, and it's inefficient for the same reasons as having specialist teams, such as a front-end team, a back-end team, a test team, and so on, which we discussed previously. When we have to sync between value streams, our planning horizon will also become longer. Aligning all persons across value streams takes time, and there's a lot of overhead, as a lot of persons are involved. You need to do knowledge transfer, you have to do planning. Basically, it is a lot of work. And the overhead and cost of it makes it hard to do it too often, meaning you can't do it very often. In this case, the framework's cadence was 3 months. So now imagine you have 100 people in each value stream, and that you need to coordinate, let's say, 3 value streams to deliver something of value for an end user. That means 300 people times 3 months. That is a lot of money. And as we all know, no software design survives the first contact with a user. And how fast we can deliver rarely depends on how fast one team is, but how efficiently and quickly we can collaborate across teams. Effective collaboration accelerates feedback and communication flows, and we need quick feedback to make better decisions. Inefficient collaboration that slows down our entire process, resulting in waiting and queues and late feedback. And slower feedback loops that increase the risk that we spend money on the wrong thing. And delivery of the wrong thing is often due to a decision made on the wrong information, and we make bad decisions all the time. So that is why fast feedback loops are so essential. Now, so we often base our decisions on incorrect assumptions or looking at the wrong variable. Many have tried to, for example, mimic Toyota's success by copying their factory machines or ceremonies, not understanding that is the culture and mindset that created the success. I hear people discuss about the perfect sprint length, and there seems to be a belief that a shorter sprint makes you more agile. This is a misconception. Agility has nothing to do with sprint length. Agility is about collaborating, delivering, reflecting, and improving in fast cycles. Having shorter sprints is not wrong when done for the right reason, but the desire to have shorter sprints often comes from a false understanding. It is not the sprint length that makes you agile, it is your ability to remove waste and how quickly you can deliver something of value that matters. So let's say we have a team that runs 2 week sprints. They complete in average 2 product backlog items per week, and the time to do regression testing and merging to trunk and packaging, let's say it takes 2 days. Sprint planning takes half a day, retro and review another 4 hours. So the team spends roughly 3 out of 10 days on deployment and Scrum activities, or 30% of their time. This is fixed time for every sprint. So what happens if you let this team run a sprint of 1 week? They will still need to spend 3 days on Scrum activities and preparing for production. Only in this case, it takes 3 out of 5 days, 60% of the time. The overhead, of course, means that now you probably can only deliver 1 product backlog item. So the activities disrupt the flow, which means you get less out of the team, and most likely you get very frustrated developers. And the reduced capacity, of course, happens because we do not consider the relationship between the batch size of what we want to deliver versus the fixed working time for deployment and Scrum activities. If you have a 1 week sprint and can only deliver one backlog item, the relative cost to put anything into production is high. And that's what you can see on this chart. It shows the relative deployment cost per backlog item, and it's high for 1 or 2 stories related to the effort. The cost then decreases and evens out at about 6 items. And since the team can deploy maybe 2 product backlog items per sprint, or per week rather, maybe a 3 week sprint is good. Going from 6 to 8 doesn't really make any big difference. But what is really the constraint here? It is really not how many backlog items the team can deliver, but the cost to deploy. If you want to have shorter sprints, you must also reduce the cost of deploying. To be cost effective, you should be able to move something into production in minutes. If not, a longer sprint might be better because of the relative cost. A shorter sprint length might actually make things worse. So now suppose you have reduced deployment time to, say, 2 minutes, and that you slice the backlog items so they can be completed in 1 day or 2 days. Then you press a button. All the necessary checks and tests are automated, and moving a backlog item to production is automatic. You can create a new increment anytime during the sprint, virtually free of charge. And if you can move a production to production daily, then sprint length is really only about deciding how often you want to do the Scrum activities. Whether you have a 1, 2, 3, or 4 week sprint length is now irrelevant. What matters is how quickly you can deploy something of value to the customer. If you run a 4 week sprint but deploy to production every day, you're actually better off than someone having a 1 week sprint deploying once per week. So the question is not to ask, how long is your sprint, but rather, how long does a customer have to wait before they get something of value? All right, moving on. So our current focus should be on finding the worst bottleneck or constraint, the current one that is. Then we address the blocker to increase the flow, and the goal is to get flow throughout the value chain. The following example is based on a real example. Our configuration manager basically set in tiers every time we had approached the deadline for a new version. Let's call him Niklas. So pretend you have a great team. They have valuable functionality ready for deployment every day. For Niklas, it takes 4 days to package what the fantastic team plus other teams have created before it is in production. He might have to merge branches from tests and so on. So on the first day, the team has delivered their first item and they hand it over to Niklas. And Niklas begins to work on this to put it into production. So now on day 4, it looks as follows. Niklas has put his first package into production and is now ready to begin to work on the next one. Now, Niklas has 3 items in his queue. It will take him 12 days at his current rate. So Niklas gets a little bit stressed when he sees how much work he has to do. But maybe he can do some extra hours of work. Maybe he can work during the weekend to make it in maybe 10 days, do some heroics. Meanwhile, the fantastic team is getting annoyed because, hey, why are our items not deployed to production? So now, what will this look like on day 16? On day 16, Niklas has 12 objects in his queue, which will take him 56 days to finish. Here, most of us shout that we need to hire more resources to solve the problem. But is a lack of people or resources really the problem? If this was a facility with physical workstations, The problems would have been easy to detect. Imagine that the team creates a package, which is a box, which is 1 times 1 meter. And whenever the box is ready, they push it to Niklas for shipping. So then Niklas would take the first item on the queue on day 1. On the 16th day, the entire room would be filled with boxes, and you wouldn't be able to put any more boxes into the room. In software, it's difficult to see inventory that accumulate, and we usually see it in a column in GA, 16 things stuck in ready for deploy, and we don't think very much about it. However, to understand then where we have the bottlenecks, we can limit the work in progress. If we, for example, limit the number of items allowed in the ready for production to 3, that would mean that once that number has been reached, the fantastic team cannot push any more items to Niklas. They wait for Niklas to be done and ready, and then he can pull an item into his work queue. And this way we can visualize bottlenecks more easily. And the entire idea is that we visualize the constraint or the bottleneck, and then we flow. In Lean books, some people refer to this as low. You lower the water until you see the rocks, and then they're easy to remove. How to solve the problem, however, is up to everyone involved. Everybody helps out with this. And perhaps the solution is to automate with more scripts. Perhaps it is to move Niklas into the team. I worked in a previous organization where in infrastructure, one day they just decided that we developers were fully responsible for all dev and test servers. And I'm really astonished they trusted us with that responsibility. We had no clue. The concept was great, and it really worked very well for all of us. As developers, we patched servers, we installed software, we made deployments, we synchronized dev and test servers, and it became natural for us. Another I see everywhere is specialization. You have this guy, he's an expert, he is the best. He can handle what take other people 8 hours, he can do it in 15 minutes. And all work suddenly begins to go through this person. We call this person. And suddenly Michael sits with all the knowledge and no one else can do the job anymore. And things begin to slow down. And as I walk around and asking, why are things slowing down? There's a Michael to be done with this and that and so on. And now, even if it takes Michael only 15 minutes to fix the problem is now he has a queue of 200 items to do. And now suddenly you have to wait for 15 days to get his attention. Therefore, the task takes 15 days, 15 minutes to fix. And suddenly those 8 hours, they seem pretty attractive. In this case, the company even assigned a person to prioritize Michael's work so he could focus on being effective. Not very uncommon. So, in this example, the organization started an agile transformation but ignored architecture and technical depth. For some reason, executives believe that we would deliver software every week by introducing agile frameworks and activities such as dailies or sprint planning and feature teams. Let's look what this looked like. We had a colossal monolith product. We checked in code in the last minute. Regression testing took 3 weeks. Component teams, lots of bottleneck persons, no working unit test, manual packaging of the product from over the wall to operations. How in the world can you expect delivery daily or even every other week when it takes 2 weeks just to do the regression testing, where check-ins are made 1 day before the sprint ends? Well, these guys, they had really peed in their pants. So much that they could hardly walk anymore. And do you think technical considerations were considered when the agile journey began? Of course not. No one understood the problem. The developers had tried to shed a light on the problem, of course. Unfortunately, those who led the change did not have the technical knowledge or education, experience, or understanding. They did not talk dev talk. So here, the non-technical agile coaches had told management about feature teams, sprints with deliveries, and they told tales that teams would magically deliver twice as much in half the time, and that culture follows structure. So about 18 months into the agile transformation, I was hired as a dev manager because I have some added experience and knowledge. And I quickly realized that the problem were due to architecture and technical depth. And the company had invested a year into the agile journey without getting any result. So my boss, he asked me, how long would it take before we reach this promised result with this agile thingy? Given that the system consisted of millions of lines of code, 20 teams who had built up technical debt for years, I thought for myself, 3 years perhaps, maybe a little bit faster if we don't add any more features. So I told him 3 years, and he just turned red in his face, and he said, "You have." So basically, what we need to do was to create a culture where we checked in code daily. We refactored code according to the principles of clean code with automated tests and pipelines, and to divide the monolith into separate testable modules. System thinking here is important because you need to understand all aspects, not just the organizational part. In this case, the management did not understand our constraint was and continued to look for non-technical to solve the problems. And letting people without technical understanding drive an agile transformation is as wise as letting them decide what type of surgery a doctor should perform, especially if the economist gets a bonus based on cost savings. So I can hear, the economists tell the doctor, no, 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 we don't have budget for a heart surgery. We can afford casters of the leg. Would that work? Yes. So in this case, management, they wanted, a shiny ship. They got a nice exterior with a tractor engine. I would rather have Millennium Falcon, which might look like a piece of garbage, but is the fastest ship in the universe. What I learned is that you need DevOps principles to be agile. Do not ignore technical depth or architecture, and always include technical people in an agile transformation. Now, for a team to be autonomous, we need to have all the necessary skills when available, right? So that the team can take something from start to end themselves without waste. At the same time, we don't want the team to be too large. And given that software development is becoming more and more complex, this will soon be impossible. Why? Well, to handle everything, you need so many skills in your teams these days. You need front end, back end, and full stack skills. You need a scrum master, product owner, UX skills, operations, testing, subject matter experts, and so on and so on. And having all of these skills in a few persons is very rare indeed. And as we shift left, we constantly discover new bottlenecks and skills required. Security, for example, is becoming a new bottleneck. Before we deploy to production, we must test the product security. We need to do pen tests. We need to ensure that our platform is hardened. And the process requires skills that few have and cost top dollar. Even worse, security tests such as SAST and DAST reviews, penetration testing, third-party scanning, etc., are usually performed last. Similar to how we did testing previously. So that prevents us from deploying continuously. It doesn't matter how often our teams can deploy. if we have to wait 3 months before we can have a pen test. So the process prevents us from releasing small batches of code because testing is not integrated into our daily activities. So security becomes a new bottleneck, preventing us from getting feedback. So what's the solution? To hire more persons? Of course not. The answer is to automate the process and introduce routines into our daily work. And the picture shows how we try to do it to map security into Scrum using some ISO certifications, basically DevSecOps. So the trick is not to add more people, but to automate and build knowledge into existing routines, no matter if this is for help desk, security testing, or whatever it is. Very hard to do in practice though. Now, how is it that we continue to do stupid and unnecessary work when we should spend time to figure out how we can do more with less to automate or streamline? I believe that Slack is an essential factor in being productive and innovative. When I read XP in 1997, there was something called focus factor. I misunderstood it as how much time you should spend on user stories. My interpretation was that the rest of the time would go to admin work, transition tasks, fixing bugs, refactoring, or other things. So I told the organization, our focus factor should be 70%. And everyone accepted, to my big surprise. I was the only one who knew Scrum at that time, and it probably thought I knew what I was talking about. But the result was fantastic. The pressure to reduce quality and write spaghetti code disappeared. We always met expectations. We had time to refactor, to fix things, and to automate. And if something urgent needed to be done, we had extra capacity to do it. One tool that came out of this was a one-click deployment tool. One developer was tired of manually moving apps to production, so he built a simple graphical tool where on the left side you can see all our projects, and on the right side you can see all the service, and then you can drag and drop. And I promise you, in that organization, no product owner would ever have prioritized this work. So the 70-30 rule gave us flow, continuous learning, and innovation. I have later tried to introduce this slack time to other organizations, but never really succeeded. They just look at me like I'm stupid. We are already working 100% and you want us to only work 70? Are you crazy? So that's it. 8 cultural problems, and the circles you can see represent what we talked about. Usually there is more than one vicious circle in an organization and they affect each other. By identifying and knowing your vicious circles, you can see how they affect each other. Then you can try to understand how a change in one place can affect other places. For example, in this case, silos led to handovers, which led to queues, which led to more coordination and management, which meant no flow. Or reducing quality means more bugs being in the pant, which cause more help desk errands, which means less focus and more interruptions that disturb the flow, and less delivery, which means more pressure to lower quality, which leads to more bugs, etc. I believe for culture to succeed, you need to focus on quality, responsibility, craftsmanship, and Slack. Together, they build inherent motivation, pride, and mastery. And that's it. And remember, even Darth Vader saw the light in the end. Whew, I had to rush it in the end. But that's it.
Yeah, thank you for your presentation, Fredrik. It was really amazing, and your hat grabbed all the show, as I see on the on chat, and also that captions at the top, at the bottom, was really interesting for our audience. So let me look on that Q&A chat. Unfortunately, we don't have any questions from audience, but of course I would like to encourage you to ask something about the presentation, about the topic. It was really interesting, and thanks for that holistic view on that, how many problems we have in implementing DevOps culture. So one thing from my side, one question maybe, if you would to recommend something what everybody can do today to change something within your team, your organization, anything, what would you recommend?
I think, use common sense. And I think, the simple thing of just collaborating and then deliver something, reflect and improve. That is basically the essence of everything. And you have to do it in quick feedback loops, and you have to learn from it. And then you do the continuous learning to make sure you get better all the time. That's the most important thing, I think.
Yeah,
And
yeah. Uh,
at the heart. Yeah.
Totally agree. That's the continuous improvement, continuous development ourselves, and continuous development our team, our organization, constant change. Yeah. So yeah, totally agree. Okay, Fredrik, thank you for your presentation. Thank you for your time. It was a really amazing, interesting presentation. And of course, really thanks for everybody who joined our architecture and DevOps teams track. It was so much pleasure from my side to be with you, to lead you through all of that great presentations. I hope you enjoyed. I really enjoyed all of that presentations, and I would like to invite you for our last presentation on the general first track, closing keynote. So thank you for your time, for being there with us. Thank you, Fredrik, for your presentation, and have a nice day, and see you next year.
Thanks. I had a great time, and hopefully sometime it will be in front of a live audience.
Yeah, I hope so. I hope so also. Thank you. Have a nice day. Bye.
You too. Bye.